Hi students, this is Shivakrishna, working as a assistant professor in Anurag Engineering College, Civil Department. Today I am explaining the topic of design of tension members. Here, already we are discussing about in the first unit types of connections. In these types of connections, there are three types of connections may be involved. That is a welded connection and riveted connection and welded riveted welded connection, riveted connection, and bolted connection. In these types of connections, we have to find out the what is the strength of the bolt and what is the strength of the plate, and how to get the efficiency of the joint. In this efficiency, after getting that, we have to check that strength of that joint. That strength it should be capable to bearing that load or not. We have to decide in this unit. In this, what type of failures may be involved in this particular joint, how to bear on that types of failures, and how to control on that failures, we should have to learn in this unit, that is design of tension members. What is meant by tension member? Tension member it is any tensile force it should be capable one member. That member it is also called tension member. Like truss. Truss is a tension member. In that truss is a tension member. In that truss, acting on the load it should be equally distributed on that related members. This type of members in this situation, we have to implement the channel sections, I sections, angle section. Many type of sections should be involved in this type of demand and type of the need. Here, first of all, what are the types of failure should be involved in that particular situation? First of all, the gross section, three types of failure should be involved in that particular tension member. That type of failures may be, one is the strength governed by the gross section of yielding, and strength governed by the net section yielding, and strength governed by the block shear failure. These types of failures may be more frequently occurred on that particular joint. This type of failure you have to overcome on that particular situation. The member should be always safe in that particular failures. So, design strength of the member, how to get that value? You have to consider the least value of this above three scenarios, like yielding of cross section and rupture and block shear. Based upon these three values, you have to consider the lesser value, that is the strength criteria you have to consider on that particular member. That is the design strength. Design strength of the member at least half strength due to yielding of cross section and rupture and block shear. And what is the yielding of cross section? How to get that yielding of cross section? Yielding of cross section failure, the area should be vary. In the situation, the type of failure may be occurred. See the design strength of the member under axial tension. What is the formula? How to get that value? Means TDG equal to Fi Ag by gamma m naught. Here m naught, gamma m naught is the partial safety factor, that is considered as 1.1. And AG is average cross sectional area of that particular section, and Fi is the yield strength of the member, that is you have to consider as the 250. And after that, design strength due to rupture. This formula, it should be 0.9 AN FU by gamma ml. Gamma ml you have to consider 1.25 as per IS 800 and 2007. What is the area? Net area here. Net cross section area it should be involved here. The rupture should be involved in this particular bolt and plate. The rupture should be involved in that particular yielding. That is, how to get that net area is B minus ND naught plus summation Pi square by 4Gi into T. Where the bolts not provided in the similar motion, you have to provide in the zigzag motion. In the situation, the gauge should be involved in that particular scenario. And after that, see here, the one particular plate, the angle section should be involved, like linked in this here two types of connections may be involved in this particular figure. That is, the one is the bolted connection and the second one is the welding connection. For how to using the bolting connection, that angle section and that member you have to provide by using the bolts. Okay, and second one, welding means each corner of that throat sections the welding should be provided. Here the bs value should be in varied from bolt connection to welding connection. Bolt connection, we are taking the bs value w plus w1 minus t. Here W1 means the distance between the end of the member to bolt where the bolt should be provided in that particular situation. That is the distance between that is called W1. Here bolt distance is not involved, so that's why only BS it is taken as W only. Single leg connections only. Double leg means another side also you have to provide, that is the double leg connections. And next section of the rupture. See here, this is the formula for single angle, that is 0.9 FU ANC by gamma ML plus beta AG naught FI by gamma M naught. Here FU, we know the ultimate strength of that plate, that is 410 we have to consider, and ANC area of the net area of the critical section, and gamma ml means partial safety factor, and beta it is an angle. How to get that beta value is using this formula, that is 1.4 minus 0.076 into W by T into FU by FI into BS by L. Okay, that is less than Fi gamma m naught by Fi gamma ml. This is also involved in the IS. We are following the IS 800 2007 only. In that page number 32, directly displayed on that by using this formula based upon the IS 800 only. And coming to sizing situation, alpha AN FU by gamma ml. And coming to block shear. Here block shear, one plate overhanging the another plate. In this type of connection only the block shear may be involved. So in this situation, we are providing the bolted connection, one plate, one bolt and gusset plate. These three plates have to rapid, due to this rapid and overcome to the one plate to another, the block failure may be involved. See here. Block shear failure, it is also seen in a weld connection. A type of failure of a gusset in the weld connection, as shown in figure. See here, this type of failure should be coming to block shear. Here plane BC under tension, planes AB and CD is in occurs by block shear. And coming to leg angle, what is the leg angle? Leg angle means it is the one of the angle section. Extra plate you have to provide it to decrease the length of that member. That situation only have to provide the leg angles. Short angles used to connect the gusset and outstanding leg of the main member. Okay, see, this is the channel member and one is the gusset plate member. These two members have to connect by one particular leg angle. Okay, and see here, this type of particular scenario, the design strength, how to find out first one. In this problem, determine the tensile strength, plate 120 by 8 mm and 12 mm thick gusset plates. On the yield strength of the ultimate strength is 250 and 400. So here given the steel value 400, so directly substitute in this 400 value. Here using the bolts dia 16 mm. First of all, you have to find out the strength of that member. We have to take in the yielding of cross section and rupture and block shear. First coming to cross section, what is the formula? Fi Aj by gamma m naught. Here Fi is 250 and Aj, length of that member and thickness of that member. Length it is 120 and thickness is 80. So 120 into 80, 960 mm square, and gamma m naught is 1.1. So all values should be substituted in this equation. We are getting the value 218 kilonewtons. That is the strength. And what is the load? Load should be acting on that member is load should not give in this particular situation. So we have to take the value. And so first of all you have to take the member. Based upon that member, this is the value. Why? Because TDG into Fy by 1.1. After that, this getting this value should have to enhanced by 15 to 20%. So in that situation, we are taking the cross sectional area from the steel tables. This is the trial section only. Okay, after trialing that member, if you have to satisfy, you have to just provide on that member. Trial section, it is chosen by steel table by gross area. And coming to step 4, strength of the section is checked as per IS code. How to get the strength of the section? By using cross section, rupture and block shear. Using these three methods and getting the value of that particular member. Okay, coming to block shear, what this is the formula so you have to use to find out the block shear. That is AVG Fi by root 3 gamma m naught plus 0.9 Fu ATN by gamma ml, or TDB equal to 0.9 Fu AGN by root 3 gamma ml plus Fy ATG by gamma m naught. After checking the design strength, after we have to calculate the least value on that particular design strength. We have to take the lesser value, and after that, if the strength of that member is very high compared to load, it should be okay. But it should be coming to less value due to the load. It should be revise that cross sectional area and revise that member. And the Slander's ratio how to check. How to get the check the Slander's ratio value? Based upon the steel code book, we have to L by 350. We are using the tension members. So L by 350 and the maximum span by 20 and 350. This type of formula I have to kept in that particular situation, and this is also one of the check to find out the strength of that joint member. These all are steps. This is the design part of the tension member. One particular design member, any design member you have to design. First of all, you have to take the cross sectional area due to that load. After cross sectional area, based upon that cross sectional area, we have to consider the one particular angle section or any I section or C section from the steel tables. After getting the steel table, we have to use the connection. So for that connection, we are taking the values of strength in single shear and strength in bearing. Based on these values, I have to take the lesser value and find out the number of bolts for fixing the gusset plate to angle section. This type of connections I have to implement it, and after making the connection, this connection should be safe or not, you have to check. So based upon that check, we have to following the three guidelines as per IS 800. That is one, first of all, we have to take the yielding of cross section, and the second one due to rupture you have to consider, and third one due to block shear you have to consider. After getting these 5 steps, you have to simply to find the design of the one particular tension member. First, you have to take the gross area. Based upon that gross area, we have to select the one trial section of that angle section. After that, you have to provide the number of bolts for fixing the gusset plate to angle section. For this connection, it should be bearing that strength or not, you have to check. One particular one good tension member, it should be strength should be very high and load should be very low. This type of phenomena it should have to maintain on that particular situation. The design of that particular tension member is very safe. In that otherwise it should be less than that load strength value. The revise the section and do this type all type of this do all steps how to consider and do did doing on that particular situation. Okay, and these type of failures are commonly occurred in the one particular tension member like trusses. Trusses or any structure, any stanchion. This type of failure should be involved, and this type of loading action should be acting on that particular scenario. It should be very commonly we are occurring. This type of tension members and leg angles and splice is the one of the extra plate I have to provide on that particular scenario. This plate should be improving the strength of that member only, and after that next one, coming to splice and leg angles. Leg angle, it is the reduce the length of the member for saving the purpose of that material. This type of all design procedures should have to keep in mind, and just you have to follow the this simple few steps. You have to find out the design of tension member. Okay, thank you students.